Today we're going to be starting with our word problems. I know you guys love word problems so much. A lot of kids generally have a great dislike for them. But we really need to know and understand our word problems because the majority of your Regents exam at the end of this school year are word problems. So you've got to get used to it. The problems get pretty wordy sometimes. So I have up here for us first is how to know when you have addition, subtraction, multiplication, and division by looking at the words. So if they tell you plus, sum, added to, increased by, more than, exceeds, those words all tell you you're using addition. So they'll have those words within the word problem, so you need to know when you see those, okay, that means I'm adding two things together. We just have to figure out what those two things are. For our subtraction, it's minus, difference between, subtracted from, decreased by, less than, reduced by, and diminished by. Those are our keywords telling us it's subtraction. Now, I always like to put a little star next to more than and less than. When you see those words, you need to flip the order of what you're dealing with. Like they say that it's 4 less than x. When I say you need to flip the order, that means the 4, even though it's written first, would come after the subtraction sign, and your x goes before it. Less than and more than means you need to flip that order. So it happens with more than also, like this one, b more than a means the b comes after and the a would go first. So less than and more than, they flip. For multiplication, they'll say times, product, multiplied by. The word of generally means to multiply. Another one they like to do, they'll say it's twice something. That means you're multiplying times 2. You got to remember, any area problems also means that we are multiplying. When we get into some shapes, area means that we have to multiply them. Do you remember which one means we have to add them? If areas multiply? Begins with a P. Joe? Rhymes with perimeter. Perimeter would be you would add up all your sides. So if it's a 5-sided shape, you're adding up all 5 sides. If it's a triangle, you're adding up all 3 sides. And then division, as you can see, we don't have many choices. Divided by, quotient, and keeping in mind that one concept that a lot of us are still struggling on. If you have a over 4, that means it's a divided by 4. So let's just practice translating from English words into algebraic expressions. It tells us up here in the directions to use the letter X to represent our unknown. So what I'm going to do is I'm going to give you like a minute. Let's see if you can figure those 4 out. I feel like these first 2 were easy, and then the third one was like, oh my god, what the heck is that thing saying? And then the fourth one wasn't too bad. So let's take a look at these. First one, a number increased by 9, so x plus 9. As I said, pretty easy. 2, the product of 7 and the square of a number would be 7x squared. Product means we're multiplying, so you're doing the 7 times the x squared. 3, a number raised to the 3rd power, then divided by the difference between a number and 6. So a number raised to the 3rd power would be your x to the 3rd, but it's divided by the difference of a number and 6, so it would be divided by x minus 6. Did anybody get that on their own? Yes! All right. If you did the division sign instead, you would just have to have put the x minus 6 in parentheses so that you know the whole thing is divided by that. If you don't put it, then it's just saying it's only divided by the x, but it's not. It clearly says it's divided by the difference between the number and 6. And then the last one, 3 less than half a number. So one way we could do that is 1/2 x minus 3, or x over 2 minus 3. 1/2 x, x divided by 2 means the same thing. So either way you wrote that would have been fine. All right, let's try some. So here are my recommendation. Well, these are the steps you want to use when you're solving a word problem. You want to read the problem carefully. That is essential, especially now, because they like to give you lots of extra information that you don't actually need. They like to give you little tricks, like at one point they're talking about inches, and then the next point they're talking about feet. So you need to pay attention to that so you know to convert between the two different units. So you got to read it carefully to make sure you fully understand what's happening. We then have to represent the unknown by a letter, meaning you have to write a let statement, or if it's talking about a shape, you can draw a picture, and that is your let statement. But basically, you have to know what is it that we're trying to find. That's our let statement. We need that. So then we're going to translate each word phrase into algebraic symbols, meaning we're going to write our equation after we have our let statement. You want to find the solution set for the equation. Sometimes you may have to plug back in to find other ones. So that's basically just telling you got to solve. You want to check to make sure your answer makes sense. For example, if we're talking about the length of the side of a triangle and I get -10, that doesn't make sense. You can't have a negative length of something. So I would have to go back and check my answer. Or if I'm talking about something small and I get a number like 1,000 as my answer, that's probably not going to be my answer. And then we got to make sure we answer the question by writing a sentence. We do quite a bit of writing now in math, because a lot of times you need to write what is your answer, explain your answer, how did you arrive at your answer. These are all new questions that we use a lot now. Rounding, you need to make sure you pay attention to where you round to. Money, they don't generally tell you where to round to, so you got to go to the nearest cent, which is the nearest hundredth, 2 numbers after the decimal. So let's take a look at our first example. If 5 times a number is decreased by 12, the difference is 9. What is the number? So what are we trying to find? What are we trying to find? No, we're trying to find the number. So we're going to say let x equal the number, because that's what we're looking for. So there's our let statement. We now know what we're looking for. We're looking for a number. So if I get a smiley face as my answer, it's probably not my actual answer. So now we can go back and write our equation. 5 times a number. What would that look like? 5x is decreased by 12. Minus 12. The difference is 9. Means that equals 9. So you got to take each little part, because a lot of times when you read that whole thing together, you're like, what? So we'll add 12 to both sides. So I get 5x equals 21. Divide by 5. What does x equal? 4.2. Is 4.2 a number? Yep. Because you'd have to be careful. Because what if it told me to find the integer? Is 4.2 an integer? No. So that wouldn't be an answer. But they just told us a number this time, so we're all good to go. So then we can say the number is 4.2. Taking a look at our second one there. The larger of two numbers is 6 more than twice the smaller. Their sum is 27. Find the numbers. So what are we looking for here? The numbers. How many numbers? Yes, more than one. How many numbers are we looking for? 2. So that means you need 2 let statements. 2 numbers, 2 let statements. So they tell us the larger of 2 numbers is 6 more than twice the smaller. So I have to state what's going to be the smaller number before I can figure out what the larger one is. Okay, you want to use y? Okay. So let y equal smaller number. So what would we write for the larger one? Nope, can't use x. One variable. They told us the larger number is 6 more than twice the smaller number. Your next? Ooh, so close. You're just missing one thing. It's twice the smaller, so it's 2y plus 6 equals the larger number. Y plus 6, larger number. For our equation, they told us their sum is 27. Sum means we do what? Add them. So my smaller, which is y, plus my larger, which is 2y plus 6, equals 27. Now we have an easy equation to solve, just like we've been doing the last couple of days. We got some like terms to combine. Y plus 2y, 3y plus 6 equals 27. Now what? Subtract 6. So 3y equals 21. Y equals 7. So we know our smaller number 7. How do we find our larger one? We got to plug 7 into our expression up here. So 2y plus 6. So we got to do 2 times 7 plus 6. 20. Then we just have to write our answer in a sentence. The numbers are 7 and 20. All right, so I think we have 3 more word problems to do. So we have Rachel and Siobhan belong to different local gyms. Rachel pays $35 per month and a one-time registration fee of $15, while Siobhan pays $25 per month but had to pay a $75 registration fee. After how many months will Rachel and Siobhan have spent the same amount on their gym membership? So what are we trying to figure out here? The months, because it asked us, After how many months? So we're looking for the number of months. So let M equal number of months. So let's see here. Rachel, what does she pay? What does Rachel pay? She pays $35 per month, and she also paid a registration fee of $15. How would we rate that in algebra, man? There you go. So there's the expression we would use to figure out Rachel. She pays $35 a month plus her $15. So Siobhan, what would hers be? She pays $25 a month, 25M, plus a $75 registration fee. So we are looking for when they've spent the same amount. So what do you think I do with those two things? No. No. Set them equal to each other. We're looking for when they're equal, when they're the same amount. Yeah, I could tell where you were going though. So 35M plus 15 equals 25M plus 75. So now I got to get my M's together. So 10M plus 15 equals 75. Now we want to get our numbers together. So 10M equals 60. What does M end up equaling? 6. So we just write our sentence. After 6 months, they will pay the same amount. So our next one, number 4, the number of children's tickets sold to Comic Carnival exceeded 3 times the number of adult tickets by 10. If the total number of tickets sold was 130, how many of each kind were sold? So what kind of tickets are we talking about here? Comic Carnival, yep, but do children and adults pay the same amount? No, so really we got 2 kinds of tickets. We got adults tickets and we got children's tickets. So, we need 2 lat statements, one for the adults, one for the kids. They tell us that the number of children's tickets exceeds 3 times the number of adult tickets by 10. So I can't figure out children's until I know adults. So what can I call adults? Okay, we'll use A. So let A equal number of adult tickets. So for the children's, it exceeded 3 times the number of adults by 10. Jessica? Perfect. 3A plus 10 equals number of children's tickets. Because if you remember, exceeded, that was one of the ones under the addition column. So that told us to add the 10. It exceeded it by 10. And then it said 3 times the number of adults. So that's why we have 3A. That's 3 times our adults. So we had a total of 130 tickets. So our adult tickets plus our children's tickets equals 130. And again, you guys know how to solve these. So go ahead, solve for A. Get A equals 30. Woo! But we still have to figure out the number of children's tickets. So I got to take my 3A plus 10. So I got to do 3 times 30 plus 10. 100. So what's the last thing we need? Sentence. There were 30 adult tickets. And 100 children's tickets. Alright, then our last one here in our notes. Emily has $1.45 of change in her pocket. She has 1 more dime than nickels, and she has 1 less quarter than nickels. Write an equation that could be used to algebraically determine the number of coins in her pocket. Then solve the equation and state how many of each coin she has. So how many different types of coins are we talking about? Dimes, nickels, and quarters. So 3 types of coins, 3 let statements. So we have to figure out which one is our X, which one's going to be on its own. So it says she has 1 more dime than nickels and 1 less quarter than nickels. So both dime and quarters are compared to nickels. So I got to say let X equal number of nickels. So if she has 1 more dime than nickels, what would I use for my dimes? Jessica? X plus 1. X plus 1 equals number of dimes. And then 1 less quarter than nickels. So X minus 1 equals number of quarters. There's our let statements. Now for the equation, the tricky part is that she has $1.45. When we go to write our equation, we have to remember to include the value of the coins in the equation. So a nickel is worth how much? But how do we write that? 0.05x. Because they told us she has $1.45 and change. We got to make sure we include these. So how much are dimes worth? 0.10. So we got to do 0.10 times x plus 1. And then quarters, 0.25 times x minus 1. So I'm going going to give you guys a couple minutes. I want you to try to solve this one on your own. You've got some distributing to do first, and then combine some like terms. So we should have 0.40x equals $1.60. Divide by 0.40, and who's got an answer already? X equals what? 4. Then we just have to write our sentence answer. She has 4 nickels. Her dimes were x plus 1, so how many dimes? 5 dimes. And how many quarters? 3 quarters. Yeah, so I would have to say the trickiest part with these problems here is remembering to put the values of the coins in the equation with it.